Right, good morning. And we're going to start our unit. Um, yeah, chemical basis of life. That's what we want to discuss today. Right, good morning. And we're going to start our unit. It comes automatically, right? Um, my very first question. The environment. The environment is composed of two things. What are they? What are they? What are the two components that the environment is made of? The answer: matter and energy. Matter and energy. So, when we think of the chemical basis of life, the matter has to be considered. In order to get the approach, I write my second question. What is meant by matter? So in grade 6, actually, we started to learn what the matter is and went on studying about that. Matter is something which occupies space and has mass. We know the answer. Matter is something. Matter is something which has mass and occupies a space. Matter is something which has mass and occupies space. So the next question is the element. So what is meant by what is the uh, structural and functional. What is the structural and functional unit of matter? What is the structural and functional unit of matter? The answer is an atom. An atom. So you know that atom is the basic unit of the matter, and it is made up of subatomic particles, electron, proton, and neutron. When we go on studying about the matter, we can see that there are elements, and the atoms, there are elements, and we can discuss about the isotopes, we can discuss about the other parts as well. So my approach to this lesson is to talk about the chemical basis of life. Now, as I told you that our environment is made up of two components. One is the matter, the other one is the energy. So if it is the matter is composed of the atoms. The structural and the functional unit of the matter is the atom. And there are different types of atoms, and basically we name them as elements. So when we think of the chemical basis of life, there we want to discuss about the elements. Right. To get the approach to our lesson, I will write my next question. Question number 4. Question number 4. Okay. How many elements? How many elements are there in the environment, which are naturally occurring. How many elements are there in the environment which are naturally occurring? The answer is 92. About, yeah, 92. Then 92 elements. If then, how many elements are there in our living body? How many elements are there in a living body? How many elements are there in a living body? The answer is 25. The answer is 25. And well, what are the most commonly available 4 elements? What are the most commonly available 4 elements? What are the most commonly available 4 elements? The answer is number 1, oxygen, carbon. The highest rate is oxygen. So I write oxygen, then carbon, hydrogen, oxygen, carbon, hydrogen, and one is nitrogen. Carbon, hydrogen, oxygen, and nitrogen. So they are the 4 elements which are highly available in our body. Okay. I can go to the next question. Okay. What is the element? What is the element? Highly, H-I-G-H-L, highly available in the body. Then, don't worry about my handwriting and spelling. In the body than the others. What is the element highly available in the body than the others? The answer is not carbon. The answer is oxygen. Because oxygen is present in every component. If you say glucose, if you say amino acids, write oxygen, and to write the percentage is 65%. And my next question, question number 8. Question number 8 goes there. And the question number 8. Name some other elements. Name some other elements available in the body. In the body. So they are some other elements available in the body. They are sulfur, phosphorus, PHOS, PHOROUS. Phosphorus, sodium, potassium, calcium, and magnesium. As magnesium, chlorine, iron. Some of the other elements available. Now, when we think of these elements, now we came to our lesson talking about the components in the environment, and we discussed that they are matter and energy. And if we think of the naturally occurring elements, there are about 92, and out of them, about 25 are available in our body to make our body as a life, to give it the life. And then we just wanted to talk about the next one is to talk about the compounds. Now, contributing elements are there. They are not just occurring as atoms in our body. They're not only the atoms, right? They will be available as the compounds. I have sent this to the YouTube. I don't know whether it's going on YouTube. Do you think it's going? Yeah, it's going, right? Can anybody share it's going right here? Okay. Question number 9. This is a kind of help that I'm going giving. Anybody can join with us every day, every Sunday, 4 to 6. Too early to wake up, get up, and come to the class, but still it's worth enough because this is the summary of your lesson, right? Okay. Now, as I told you that these things will not be 9. The elements will not be available as isolated units, and they will be combined to make the chemical compounds. The above elements are not occurring as single units, but the word "but" is the informal usage of English language. So I will write units. However is more formal. HOWEVER. However, as biochemical chemical compounds. Biochemical compounds. Okay. Name 2 types of biochemical compounds available in our body. Can anybody name the 2 types of biochemical compounds available in our body? Yes. You have learned that there are 2 types of biochemical compounds. Can anybody name just to support me in the morning? No one is there. What are the two types of biochemical compounds? No idea? No idea? With reluctant to switch on the mic. A, B, I supported. They are organic compounds and organic compounds. Are the other one?
Inorganic compound.
Thank you. Inorganic compounds. Inorganic compounds. So the carbon, if you say organic compounds, when to make it an organic compound, you should have necessarily carbon. Necessarily there should be carbon, and most of the time hydrogen, oxygen, halogen should be there other than the other elements. Necessarily carbon, and most of the time hydrogen, and sometimes oxygen, hydroxides, and halogen like chlorine, iodine, right, bromine. All those things, if they are available, and we call them organic compounds. So our body, normally the organic compounds are made by the living organisms, right? Like, so we are going to study about these two types of compounds. But when you think of the inorganic compounds, they are the ones, maybe you have the carbon, for example, carbon dioxide. Carbon dioxide is an inorganic compound. Water, there you got the inorganic compound, sodium chloride, the salts. So whatever the salts available in the body, but the others that we are going to study about the protein molecules and carbohydrate, lipids, vitamins, somebody might say vitamins, right? But they are organic compounds. Right. 10. My 10th question. Name some organic and inorganic compounds. Name some organic and inorganic compounds. So what are these organic compounds? I will write organic. When you are writing, when the question is given like this, just don't write only the list of the items, but please include the subheadings as well. Then the examiner can find it easy to mark your paper. Organic compounds. There you got the organic compounds. If you can support me, it would be very nice. Yeah. Carbohydrates. Carbohydrates. May I ask you to switch on your cameras and mics so early in the morning? Proteins, lipids, nucleic acid, nucleic acids. So these are organic compounds. They are organic compounds. So what's next? Inorganic compounds. Oh, red. Red color belongs to the teacher. You should write with other colors. Inorganic compounds. The inorganic compounds are, water, then carbon dioxide,
Carbon monoxide.
carbon monoxide,
Carbonates, bicarbonates.
very good, carbonates, always the boys are in front, carbonates, carbon monoxide, and the salts like sodium chloride, they are inorganic compounds. And there is a unit that we want to study about the organic compounds and the inorganic compounds. It is just the same way that that you have the law and order that just after your schooling time and once you get into the society, you want to deal with the law and order. Not only that, even as a student, as a citizen, we have to abide, follow the rules and regulations implemented by a particular organization or a government or whatever it is. But not a single school is to teach the law and order, right? So I don't know why these people they have not introduced law as a subject for the students, right? In the same way, in your A-level chemistry, uh, I must say, half of a part of your A-level chemistry belong to the organic chemistry, but in your O-level syllabus, it is not introduced. For O-level syllabus, organic part is not introduced. But most of the A-level chemistry based on organic compounds, and it's better to know about the organic compounds, the compounds which have carbon, necessarily carbon, and most of the time hydrogen, oxygen, halogen, and so on. And remember, once you get into the A-level classes, to learn organic chemistry right from the beginning, and if you have to lose the first session of your chemistry, and you are going to lose the whole set because it's that much of work to start the journey right from the beginning. And I'm just supporting you in your A-level classes once you get into the A-level classes. Well, now we have even white vitamins you can include in that one. Well, my next question is, right? Biomolecules. Name, I must say it's not correct. Name the major biomolecules available in your body. Name the major biomolecules available in your body. Can somebody name them? I feel alone over here.
Carbohydrates, proteins, lipids, nucleic acids.
Thank you very much. Carbohydrates. Carbohydrates. No, not a single girl over here. Proteins. Lipids. And nucleic acid. Nucleic acid. NuCleic. Nucleic acids. So these are the four types of biomolecules that we want to draw our attention. And right from here, we want to go a long journey in your studies. And I'm going to just give you some idea, right? Give me 1 second. Well, now, what will you have to study from here? Give me 1 second. Yeah. Right. Now, you can see the screen. Can I share this one, or shall I use same way? You want me to share it? No. It's used like this, right? So now, there are four biological molecules, as I told you. You have carbohydrate, carbohydrates. What the other one? Carbohydrates, proteins,
lipids and nucleic acids.
yeah, lipids, nucleic acid, nucleic acid. So, nucleic acids. When you study about the carbohydrate, protein, lipids, and nucleic acids, so what will you have to study? You have to study about these things, right? What? One, you want to know the structure. You should know the structure of carbohydrates, the structure of proteins, the structure of lipid, the structure of nucleic acid. I'm just supporting you in order to summarize this. This is not the classroom for you to learn the whole theory about the first unit, the chemical basis of life. But I'm just helping you just to give the summary before you go to your exam. So you want to know the structure of carbohydrate. Just keep on reminding that. And the structure of the protein, the structure of lipids, structure of the nucleic acid. And after that, we have contributing elements. Contributing. Select next another column. The contributing elements. Contributing elements. Contributing elements. So if it is carbohydrate, what are the contributing elements? Quickly tell me.
Carbon, hydrogen, oxygen.
Carbon, hydrogen, and oxygen. Could you please, our little girls, if you can, at least one member to support me, that will be nice. Okay. If you say proteins, basically carbon, hydrogen, oxygen,
Oxygen and nitrogen.
Oxygen and nitrogen.
Very good. Thank you very much. Nitrogen is also there. So you got carbon, hydrogen, oxygen. And if you go to proteins, they are carbon, hydrogen, oxygen, and nitrogen. So the nitrogen story would give you more about the protein. We want to talk about the excretory system, and there are nitrogenous waste and how comes the nitrogenous waste into your body, and that's from the deaminification. There's amino acid is in your body, and when you may turn that one into glucose molecules in the liver, once it is absorbed by the digested and absorbed into the blood circulatory system, it will be carried into the liver by the hepatic portal vein. I'm just giving you a remindering of what you have learned in grade 11. Then the amino acid is broken into amino part and the glucose part. So that amino part will be combining with the carbon dioxide and will be making the nitrogenous waste. And the main reason to have the nitrogen waste is there you get the nitrogen in the proteins, amino acid. So lipid. What are the contributing elements for lipid?
Carbon,
Carbon,
hydrogen.
hydrogen, oxygen.
Carbon, hydrogen, and oxygen. So the carbon, hydrogen, oxygen, there are carbon, hydrogen, oxygen here, even in the carbohydrates and lipids, but the ratio of combining will be different. That's why we wanted to study about the structure of carbohydrate. And nucleic acid.
Carbon,
Carbon,
hydrogen,
hydrogen,
oxygen,
oxygen,
nitrogen,
nitrogen.
and phosphorus.
Carbon, hydrogen, oxygen. Nitrogen, is it nitrogen there?
Yes, sir. And phosphorus.
And phosphorus. So this is how the structure there and the contributing elements, right? Then we want to study another one under the four types of things. What are the others? Well, we want to study about the users, basically users or the applications, uses of these carbohydrate, protein, lipids, and nucleic acid to our body. What are the uses? And there's a nice word, I think, I can't remember. What's the word that they use? Disaccharide, polysaccharide. Yeah. So we want to discuss about the uses, significance of carbohydrate. Your book suggests significance, the significance of carbohydrate, protein, lipid, and nucleic acid. So you want to know if you can have this chart in your this book. So you when you are studying, just refreshing your knowledge and recalling what you have learned, you can find mentally find the answers. So what's the answer? What's the answer for the structure? How is the answer structure? Take the piece of paper and then keep going, writing. And if you are getting a struck out, if you got a struck in one place, and then go to the textbook and refer that one and then proceed. I'm supporting you, right? And this is a kind of revising. Well, users or the significance, I must say, significance of the uses of these carbohydrate, protein, lipid, and nucleic acid. I'm not going to ask about that one. And the other one that you have to study about the tests relevant to this one. So if you say carbohydrate, and as we know that carbohydrate has the starch, the glucose, and the disaccharide, the sucrose, yeah. Then the test to identify the starch test, the chemicals that we have to use to do the starch test. What is it?
Iodine solution.
Iodine solution, iodine test, and carbohydrates. The other part is, if you say disaccharide, sucrose. How is it test?
The solution is Benedict solution.
Benedict solution.
Yeah, Benedict solution, but straightway I think you can't take the sucrose with the Benedict solution. First, you have to break that one into the smaller parts, the monosaccharide, and then only you have to go with the Benedict test. So how can you break this sucrose? Before adding Benedict solution, you need to add some other thing. What's it?
By adding few drops of sulfuric acid.
Excellent. A small few drops of dilute sulfuric acid. First add to the sucrose and then go with the Benedict solution to get the brick red precipitate, right? So that is how for the carbohydrate and the monosaccharide, the glucose test. The Benedict solution. So monosaccharide for monosaccharide, the glucose has the test. So you can let's keep going on writing, and then you will have the answers for this one. I just giving you a quick reminder of what we have to study. Well, if it is protein test, what is the thing that you have to use? For the protein test?
Biorate test.
Biorate test, and it is the combination of sodium hydroxide and copper sulfate. Yeah. Protein test, it is done by sodium hydroxide and copper sulfate. You take the same volume and then the extract of the food which has more proteins like egg white, dal solution, and then put and then see the color change. Okay, the lipid test.
Sudan 3 test.
Sudan
Sudan.
3 test. Sudan 3 test, excellent. And is there any test to identify the nucleic acid? No. So these are the things we want to study. And there are some interrelated experiments regarding this one. Interrelated. I mean, if you say the enzymes, if you say enzymes and carbohydrate, enzymes and carbohydrate, you know that carbohydrate is available in our body, in the plant body as well. The enzyme amylase can convert the polysaccharides into monosaccharide naturally, because it is a wonderful thing that's happening in our body. It's a wonderful thing that happening in our body. If you take a plant, right? If you take a plant, the plant would grab the sunlight, and by using the materials from the environment, such as water from the soil and carbon dioxide from the atmosphere, energy from the sun, and it converts 6 moles of carbon dioxide with 6 moles of H2O. By using energy would make 1 mole of C6H12 or 6 with 6 moles of oxygen gas, right? 6 mole of carbon dioxide with 6 mole of water and 1 mole of glucose molecule and 6 mole of oxygen. So now you can see you need to have this energy, sunlight, 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 and especially you need to have the chlorophyll, otherwise you can't do it. Chlorophyll, right? Now, my most interesting part over here is that you see this one produced over here, glucose, will be converted into liquid sucrose, and then translocate throughout the plant body, translocate throughout the plant body, and then stored as a starch. As you can see that the naturally occurring carbon dioxide and water is used by the sunlight, chlorophyll with the help of sunlight, the energy stored in the glucose molecule converted into liquid sucrose, and this is liquid sucrose, and then transported throughout the body and stored as starch. The starch, we will be taking a starch as our food. And then in the digestive system, if you can remember, grade 11, I'm sorry if your grade 10s are here, you will be learning them in your grade 11 class. When you go to the digestion, the starch digestion starts with the mouth, that is salivary amylase. From the mouth, the salivary amylase convert starch into maltose. So that's the disaccharide. Now see, in grade 10, we study about the biomolecules, carbohydrate, and there are polysaccharide, disaccharide, monosaccharide. Polysaccharide starch, polysaccharide in our body, like we have the polysaccharide glycogen and the starch glycogen. That is the polysaccharide, starch in the plant body, polysaccharide. And then disaccharide. In both, it may be sucrose, disaccharide, but we can't absorb sucrose into our body. We can have only the monosaccharide in our body. We can absorb only monosaccharide. So the plant makes polysaccharide, disaccharide. That's a starch, sucrose. Then, when we want to get it into our body, we can't get the starch straight away in our body. If somebody is to get the starch and inject into our blood circulatory system, my goodness. So it is not good. And if somebody gets sucrose and it's injected into our blood circulatory system, it will reject because the blood circulatory system can transport only the monosaccharides. So conversion of this polysaccharide into monosaccharide will be done in the digestive system. Salivary amylase convert polysaccharide starch into disaccharide, that is maltose. And when you go into the stomach, no digestion there. And if you go to the small intestine, which is started by the duodenum, from there, the maltose that's converted, that's produced from the starch at the mouth, plus the amylase that's produced, that's supplied into the small intestine by the pancreas, will be acting on further the starch and will be converting that into the maltose, and then from the enzyme maltase will make the glucose. So that's the story. In the plant body, carbon dioxide, water will be making monosaccharide, glucose, and then convert into sucrose, and then convert into starch. So the plant body, that's that one. In our body, the mouth, the digestive system would take this polysaccharide, will be converted into disaccharide or the maltose, and then will be converted into the monosaccharide, glucose, and will be added into our blood circulatory system. After getting into our blood circulatory system, what will happen? The glucose is converted into glycogen, right? That is what happened in our body. Converted into glycogen and will be stored in our body, especially in the liver. By whom, by which will be this conversion is done? There you have insulin hormone produced in the pancreas. There are the isles of Langerhans to produce the insulin hormone and glucagon hormone, glucagon. So the glucagon converts glycogen back to glucose. Glucagon, I can't remember the spelling. Glucagon will be converting glycogen into glucose. If you, whenever you want to make use of it. My question is, well, if this is happening in our body, isn't it happening in the plant body? I mean, the starch, how can the starch be converted into glucose in the plant body? Does it use, do you think? This is a simple question that I have. We have to convert the starch, we have to convert the glucose into glycogen and store it in our tissues. And then whenever we require the glucose back for our cellular respirations to generate the energy, we need to get it back by using the glucagon. Well, what about the plant body? Do you think that plant body has to convert the starch into monosaccharide? Yes or no? Yes or no? Just support me. Does the plant have to convert the starch into glucose for its use? Yes or no? We didn't hear. Somebody spoke, I saw.
No. No.
All right. Any other answer?
No.
No. Any other answer? Well, thank you for your contribution and giving me the idea representing all the student population over here. The answer is yes. Yes. You forgot. You forgot. If you want to get amylase for your test, you don't have amylase. In your laboratory, you don't have amylase enzyme. How can you find amylase enzyme then? You take what?
Saliva.
Huh?
I'm not sure, sir. Saliva.
No, not saliva. Germinating seeds, if you can remember. Germinating seeds, you take some gram, the gram seeds or cowpea seeds. You let it start to grow, start to germinate, put into water for about a few hours, and then you can see that it starts to come out with the roots and the shoot system. But before that, the stored starch in the seed start to convert it into glucose for the cellular respiration. The cellular respiration is very high. And if you have paddy seeds, a collection of paddy seeds in the sack, right? And you just put your hand and see the temperature, the heat energy there. It's very big. Even sometimes you might feel like burning of your hand because I have the experience by the time that my work in the paddy fields during my childhood. My father and my brothers, I could remember that they put that one into water and then for about night time, and they take it out and then keep a huge weight on it. And by the time that it's germinating, it makes a big heat energy. Means that the cellular respiration occurs. So in the plant body also, they are not storing the starch in the seeds, in the stem or stem tissues, the cortex tissues for our use. No, they only store that one in the fruits for our use as a way of self-tasting for the process that contributing to propagate their plant generation by dropping the seeds in some other places, and as a kind of say thank you, the plant gives us the food. Well, what I want to tell here is that the plant body, yes, they convert the starch back into sucrose, back into the glucose by using the amylase enzyme in the way that we do, right? Germinating seeds are taken to convert the starch into the monosaccharide glucose. Well, so that's happening in there as well. So this is the story we are talking, and I gave you the summary of this one. How do you feel about our going? Are you happy? Are you satisfied with whatever the things that we have been discussing right now? Yep or no?
Sir,
Yes,
Yes.
sir.
Yes.
Very much supportive. Well, if yes, then I must say, whoever watched this video on YouTube live, or yeah, or you can come and join with us our Zoom class. The link will be published just below this YouTube video, or I have the websites 100.com. There you can go to the website 100.com web page. You can go there and see my productions like this. And every Sunday from 4 to 6, we will be discussing the previous lessons. If you are getting ready for the O-level exam, and if you are going to the exam, we will be discussing about each questions. And today we just started with the first unit, and probably next week will be the physics lessons. I know that it's too easy for you to understand about the motions in the straight path, the motion of the objects in the straight path, talking about the velocity, acceleration, and all this stuff. Okay, let's get back into our lesson and keep going on writing the questions and answers. Is that okay? You happy about the elaborations and expressions over here?
Yes, sir.
Yes, sir.
Fantastic. And going to the other one. The question number 12. Question number 12. How beautiful early morning to listen to this chirping of the birds. I can hear a cuckoo bird is calling upon maybe his partner or her partner. Why don't you wake up and come over with me to have some fine food? Right. Question number 12. Name the major biomolecules available in your body. And let's discuss about the carbohydrate. What are the what are the what are the types of carbohydrates? Carbohydrates. What are the types of carbohydrates available? Right, basically, I like to listen to a female voice this time. I like to listen to a female voice this time. What are the three types of carbohydrates?
Monosaccharide, disaccharide, and polysaccharide.
Thank you very much. Nice to hear that voice. Monosaccharide. Monosaccharides. Monosaccharides. Second, disaccharide. Disaccharides. And three, polysaccharides. Monosaccharides, disaccharides, and polysaccharides. My next question, question number 13. Right. What are the three types of monosaccharides? What are the three types of monosaccharides? Monosaccharides. What are the three types of monosaccharides? Again, the chance goes to a female voice. What are the 3 types of monosaccharides? Yeah. Now it's okay for you to switch on your mic and to speak because the others also might have waken up now. If it is to speak early in the morning, just like 4:30,
Glucose,
others might.
fructose, galactose.
Yeah, thank
Glucose, fructose, galactose.
you. Glucose, fructose, and galactose. Yeah. Are the boys first or are the girls first?
Boys first.
Fructose. Glucose, fructose, and galactose. Galactose. I wrote glucose, kind of new thing. Glucose, fructose, and galactose. What made you to think that the boy is first? Right. Just a simple example, you might say that the boy is first. But if you think that the boy is first, you might not get a cup of tea right at your table, right? Are you going? Yeah, you're going to tell you that you are going to make up your cup of tea yourself and the breakfast yourself without your mommy's help.
පුළුවන්.
Emotionally, yes, not practically.
පුළුවන් එන්න.
I know. What about the girls? Do you agree with this little boy? Poor, innocent, helpless boy?
කෑ ගහන්න එපා මෙතන කොල්ලොත් ඉන්නවා.
No, sir.
කවුද එයා?
Made a cup of tea.
දැක්කනේ.
Okay, could you please tell me how many teaspoonful of sucrose will be added to the cup of tea to make it lovely and right? Just a simple question. How many teaspoonful of sucrose, sugar, should you add to a cup of plain tea?
මන්නන් දෙකයි දෙන්නේ.
1.5.
Thank you. What is the exact amount? I'm not going to ask about the girls to put them in trouble.
මොකද උන් හදන්නේ කෙලින්ම සීන් නැති ටීම්.
I didn't know.
They
How many teaspoonful of sugar should you add? It depends
So,
on your
I mean-
flavor.
So
like two.
නවීන දානවා මේ 70 පාත් සීනියන් පාත් දාන්න.
Well, if I come your home, it is different. You know,
උවා.
to express the strong bond and the love towards the particular person, the number of teaspoonful
Holy
of sugar depends on. So if I come
Holy
your, yeah. Okay, let's go to the next question. Just a little break after talking about more than 1 hour and 10 minutes. Right. My next question. What are the 3 types of disaccharide? What are the 3 types of disaccharide? Disaccharides. What are the 3 types of disaccharide? Could you please tell somebody?
maltose, sucrose, lactose.
Yeah, maltose, 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 sucrose, and lactose. Maltose, sucrose, and lactose. Right. And I'm going to ask you the next question. What are the 3 types of? What are the 3 types of polysaccharide?
Cellulose, starch, glycogen.
Yeah. Cellulose. Yeah, it just say starch, STARCH, cellulose, and glycogen. Only these 2 are available in plant, and this is in animal tissues. plant tissues, animal tissues. Okay, plant tissues and animal tissues. Well, my next question, write 16, right? Write the common formula of each of the above three categories of carbohydrates. Okay, the first one, monosaccharide. Monosaccharides. What is the common equation? C6?
C6H12O6.
C6H12 or 6. Then disaccharide.
C12H12 and O11.
C12H22 or 11. C12H22 or 11. And the last, polysaccharide.
C6H10O5. 20.
Yes. You say C6H10O5 times N, whereas N number of monosaccharide molecules. Number of monosaccharide. Number of monosaccharide molecule. Monosaccharide molecule, right? Well, we keep going on talking about this one. Disaccharide is made of, yeah, we can have, right, 17. How is monosaccharide molecule produced? MOLECULE, right? Not double L, right? Molecule produced. Yep. How is the monosaccharide molecule produced? The answer? Carbon dioxide, how many molecules? How many moles? 6 CO2, 6 H2O together will make C6H12 or 6 with the oxygen. 6 mole of oxygen. Can ordinary cell do this one? Can't. You need to have the chlorophyll. Otherwise, you can't do it. Chlorophyll. Sunlight. In our body, it is just not made, but it is. It will be formed by some other polysaccharide. In our body, we can't make this. Only the plant cell can do. Can all the plant cells do it? The answer, no. Only the plant cell which have plant cells which have chlorophyll can do it, right? And question number 18. Question number 18. The common, question number, what is the common molecular formula of carbohydrate? What is the common molecular formula of carbohydrates? What's the answer?
CXH2O.
CXH2O.
H2O times Y. CxH2O times Y and 1. Right? Question number 19. Question number 19. How is a disaccharide molecule is formed? Disaccharide molecule is formed how? The answer? Monosaccharide plus monosaccharide would make disaccharide plus
Water molecule.
water molecule. Actually, this is not a permanent one. It is reversible. It is a reversible to 6H12 or 6 will be contributing to make C12 H22 O11 plus H2O, and this is reversible. This is reversible. The water molecule is removed, that you can see, right? If you can remember, the activity done by the female bee, it takes all this monosaccharide and keep it over there in the beehive, keep going on, drying up and removing water molecule and then converting that one into sucrose, right? They are very busy with that function, letting it happen, convert the glucose into sucrose, and we people go and take this beehive and eat their food, which is very bad, like saccharide. Can anybody say how polysaccharide is made? By removing water molecules. It's a combination, long chain, right? Yeah. Now we studied about the disaccharide as maltose, sucrose, and lactose. My 20th question. Question number 20, right? Explain how the sucrose molecule, come on, lactose molecule are made. Explain how a sucrose molecule, lactose molecule are made. Sucrose. What are the contributing things for the sucrose?
Glucose and
Glucose
fructose. And
plus
fructose.
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 Yeah, will be converted into
Sucrose
sucrose
plus
and water. And lactose,
galactose plus
Plus
glucose,
glucose.
converting into lactose plus water.
glucose plus galactose. Galactose will be contributing to make lactose plus water. And I like to take you into the unit in grade 11. The same thing we study on the other way around, right? What is it? How is sucrose digested in the small intestine? Yep. How is the sucrose digested in the in our small intestine? And how is lactose digested? How is in the small intestine? Yeah. If you can remember the digestion of food, this is written for grade 11. Digestion of food. Digestion of food. Well, it is, give me 1 second. Yeah, digestion of food. First, in digestion of food in the small intestine. What does it disaccharide? Sucrose. How is sucrose digested in the small intestine? At a small intestine. Yeah. Sucrose into the same thing what we learn now will be on the other side. The way of forming sucrose is a glucose plus
Fructose.
fructose. Glucose plus fructose will be converted into sucrose. In our body, that sucrose, we will take a cup of tea, for example, and it has the sugar, the sucrose. And then when I drink that one in, and then it will be going to the stomach and no digestion and will be sent to the duodenum, right from the starch digestion, the sucrose digestion starch. Okay, the sucrose digestion is done by which enzyme? Which enzyme?
Sucrose.
Sucrase. It's always sucrose, sucrase, right? Lipid lipase, like that. Polypeptide peptidase, the enzyme. Polypeptide by peptidase. Lipids by lipase. Sucrose by sucrase. Maltose by maltase. The enzymes, ACE. Sucrose will be producing what will be produced? Glucose plus fructose. So they are both monosaccharides, so that can be absorbed into our blood circulatory system. So sucrose by sucrase into glucose and fructose. This is the digestion of food for grade 11. So grade 11 people, the same thing in the reverse. Okay, we'll go to next part. Are you happy about the lesson up now?
Yes, sir.
What is very much supportive. Yeah. It's worthwhile of coming over here and study. It is worthwhile of watching this video as well. For the first time, I'm giving my lessons on YouTube. So I have been teaching more than how many years, right? Right from March last year, online classes, but it did not give online. 21. Question number 21. So my next question. Yeah. We went on talking about the glucose. When observing a plant cell and an animal cell. When observing a plant cell and an animal cell, write the types of polysaccharides available. When observing a plant cell and an animal cell, write the types of polysaccharides available in them. Yeah, what are they? Very late comer. Why did you get late, the one just now joined in our class? Yeah, what are they? Plant cell. What are the polysaccharides available in a plant cell?
Cellulose.
Cellulose. The other one? Starch. Cellulose where in the plant cell?
In
Cell wall.
in fibers.
Exactly. Cell wall. In cell wall. In cell wall. The starch. The starch. Cytoplasm. And what about the animal cell?
Glycogen.
Glycogen granules. Glycogen granules in plasma. The starch granules. Yeah. You don't have starch granules in animal cell, and the same way you can't have the glycogen molecules in the plant cell as well. My question number 22. Are you tired of listening to me? I think yes or no? Right. Are you tired?
Little bit.
Huh?
Little bit.
Little bit, right? Significance of carbohydrate. Write the significance of carbohydrates. Write the significance of carbohydrate. 1. As an energy source. As an energy source. Another one.
As a storage compound.
Very good. As a storage compound. as a storage compound. 3. Cellulose as a structural components, as a structural component in plant cell wall, cellulose. And 4, as a constituent of nucleic acid, as a constituent, of nucleic acid, Now, test 4, we have to go with the test 23. Test to identify carbohydrate. Write the test to identify the following carbohydrates. Number 1. Just to identify the carbohydrates, mention the chemicals used. Mention the chemicals used. Mention the chemicals used. Yeah, first one.
Starch test.
Yeah, starch test. What is the name?
Solution is iodine solution.
Yeah, iodine test. Iodine test. The solution?
Iodine solution.
Iodine solution. Glucose. What's the glucose test?
Benedict test.
Benedict
Benedict.
test. Benedict. Benedict test. What are the things taken?
Benedict solution.
Benedict solution. And the third one? Sucrose.
Sucrose.
Sucrose test. Okay. And actually, is there a name for that? There's no name. And what are the contributing things? What should you use?
Benedict solution and few drops of sulfuric acid.
Yes, diluted H2SO4. And then Benedict solution. Well, 24. Right. A group of students did the following experiment. A group of students did the following experiment. They took few germinating green gram seeds and collected the extract of it by grinding and mixing with water. Mixing with water. Then they took wheat flour and added Benedict solution and observed at the same time they took another sample of wheat flour and added the extract from actually I just made a little change. A group of students did the following experiment. They took the two germinating green gram seeds and I collected the extract of it by grinding and mixing with water, correct? Then they took wheat flour and added not Benedict solution, iodine solution, iodine, iodine solution and observed. At the same time, they took another sample of wheat flour and added the extract from green gram and iodine solution. Iodine solution. They observed both samples after few hours. After few hours. My question now, number one. What are the possible observations? What are the possible observations? What are the possible observations? Can you understand what the question? Yes or no? Yeah. The set of students, they took a starch solution with flour, then put into two vessels, and then they extract the germinating green gram solution, took the germinating green gram, grind them, and then mix up with water, then took the extract from that, keep it aside. Then they added iodine solution to both wheat flour vessels, and then for one extract from the green gram, that grinding green gram and then kept it for a few hours and observed. So what are your observations? What are your observations? Yeah. What are your observations? Right? This is actually what happened. Now look at here. Do you want me to explain it?
Yes,
Do you
sir.
want? Yeah. Okay. Actually, this is what happened. You know, when you have the starch solution in the vessels A and B, right? The starch solution are there, and you can add iodine solution to both. So iodine solution to both. Iodine solution. This is starch, STARCH, and this is also starch. Starch is available in wheat flour. Wheat flour. Wheat can WHEAT, wheat flour. My spelling is correct, right? WHEAT.
Yes, sir.
WHEAT.
Uh.
Ayo, my wrong spelling. Wheat flour. I wrote WHEAT there. Correct. Right, wheat flour and starch, wheat flour and starch. So the very first observation is that, right, both, step one, both solutions respond to iodine test, and converts the solution into which color?
Purplish blue.
Yeah, dark purplish blue, dark blue color. But later on, what happened later? The solution with the green gram. So you have green gram, germinating green gram extract, right? This germinating green gram, that one, the extract, now the solution with the extract of green gram, gradually loses its blue color. That's the observation. This one's blue color is gradually disappearing. So that is what you have to write as the observation. Please write it down. I'm not going to write there again, right? So the this extract will be gradually losing its blue color. Can you write the reason? My next question is B. Write the reason Write the reason for the observation. For the observation. Write the reasons for the observation. What is the reason for the observation? First, the first one, the starch with iodine solution converts into dark blue color. Dark blue color. Second, the extract of green gram. The extract of green gram contains amylase enzyme. Amylase enzyme and the starch is converted into maltose. Full stop. That's sucrose, maybe, right? Maltose or disaccharide. Does not respond to iodine test. Therefore, blue color disappears. Could you understand that one?
Yes, sir.
Superbly, perfectly. Okay. Now nearly 2 hours. Nearly 2 hours we have been discussing about this one. I think for today that's enough. Yeah. You happy about our time spent over here?
Yes, sir.
Yes, sir.
Yes, sir.
And very much supportive.
Yes, sir.
Yes, sir.
Yes.
You can invite your friends, pass this message. Hey, why don't you come and join with us in the Zoom class? Plus the YouTube live. If I feel like of broadcasting it through the live, I would consider of next Sunday as well. The other one you can find it out from the anurres.com. That's my website. Go and click YouTube live. Click there. Welcome to Anurres. And then until the next revision class on Wednesday. Until then, have a wonderful time and bye-bye.
Thank you very much, sir.
Thank you, sir.
Good.
Thank you, sir.
Thank you, sir.
Stay safe.
Thank you, sir.
Thank you, sir.
Have a good day. So stay
Thank you,
safe.
sir. Goodbye, sir.
Thank you, sir.
Goodbye.
Goodbye.
Goodbye,
Take
sir.
care.
Thank you, sir.
Take care. Bye-bye. Thank you.